Andy, good to have you back. And so one of the, you can get these results, you get these pretty pictures, and it's a real challenge to look beyond the pretty pictures and come up with, engineering insight. And that's where, the engineering judgment and the real engineering, a lot of real engineering comes in. And again, it's a skill that we don't really teach. So I wanted to show you the results. If you could bring up the results
Sure,
and then, show us, we want to know your thought process as you're looking at the results, how you interpret them.
absolutely.
And let's start with deformation.
In the model, I'm plotting deformation. Now, there are deformation at different time steps. Each time step is doing something different. So I'm just going to remind myself which one is which. The very first step is preload, where we put in bolt pretension. The second is pressure, where we have pressure loaded in the system. And the final one is we add temperature, 700 degrees. All of these are cumulative. So I'm going to take a look at time step 1. And the deformation here, I would expect that the overall flange or the overall nozzle to have very low deformation at the beginning because we're just setting the groundwork for the bolt pretension. The next is the bolt pretension here. So whenever this bolt is threaded through, there will be some deformation and movement within, and that corresponds to the preload. So that's making sense. And now, if I were to look at the other loading, and Rajesh, I'm gonna I actually need to resolve this so I can get some more results. Um, so let me go ahead and do that really quickly. I'm gonna ask for total deformations at some additional time steps. And while this is solving, I'm actually going to click on solution information. This is just some bonus information where I can see this this model converge. This is how I know if the model is working or not. So it's blank to begin with. It's thinking. Let me go over to the solver output, and I can see what the simulation is thinking. So it's actually outputting some of the steps over here, and then I'm going to go back to force convergence. So it's stepping through the problem and converging on force, and sometimes it also converges on displacement as well, and sometimes moment because there are those different equations that it has to step through before getting the results. Now, I can abort the simulation earlier if I see divergence in the model. So for example, going back on force convergence, if I see this purple line continuing to go up and not going below the blue, I know that something else is wrong and I can stop before it takes too long. Okay, now I'm going to go to time step 2. This looks very exaggerated. That's because my result right here is needs to be set on true scale. So this is what it would actually look like in practice. And you can see there's a kind of a small gap between there. That I would expect because there is pressure trying to separate these two bodies, even though there's a bolt that's pushing them down. Now, when I zoom out, I'm going to turn off elements so I can see various colors. And I'm going to exaggerate this so I can see what's going on. So this is a factor of 100. So it's going to be exaggerated. That's okay. So this is the video playing through the entire simulation. I'm just going to do the pressure. So I'm just going to select this guy right here, press play, see if it makes sense. This makes sense to me. This is a fixed support up here. It's an approximation, so it's going to be fixed in space. The bottom of the nozzle should move out. That's good. Here, we're not getting as much motion from the assembly down there. And that also makes sense because we have, let me set this as a factor of 5, because we have so much material over there that it's not going to want to move as much. So I would expect that as well. Now, let's look at the thermal step. This one is more dramatic and I think is interesting. So this is true scale. And I'm going to play this on true scale. So you can actually see this thing move on true scale. If we were to look at the bottom, we can see it grow axially. And again, this is the thermal time step. So it's growing radially and axially. Now the whole video is playing where it's showing preload all the way to thermal. I'm going to only select the thermal. And if you see what I did there, I just selected the part of the video that I wanted to play, which is the thermal step. This is thermal growth. So if we did CTE times length or radius, depending on what we're interested in, times delta T, that is the deformation.